So today we are starting chapter 2, the Earth and Space. So to get us started, we are going to watch a little video on pictures that astronaut Sunita Williams took, all right, to introduce us to Earth and space. So we are going to continue on today learning about rotation, revolution, and tilt. Okay, we're going to go through these three things and what they are in relation to Earth. Okay, so we're going to start off with rotation. The Earth rotates in a west to east direction. Okay, so this is why we say the sun rises in the east and sets in the west. Are we familiar with that? Have we heard that before? Some of us? Yep. The Earth spins on its axis. Have we heard the term axis before? Yep, familiar with that. So if we can about imagine putting a pole in the Earth from the North Pole to the South Pole. All right, that pole going straight through, that's what that axis would be, okay? So the Earth spins on its axis. One rotation takes how long? 24 hours, right, which equals 1 day. Yep, that's exactly right. So one spin on its axis is 24 hours or 1 day, okay? Solar energy or sunlight, right, directly hits only the half of the Earth facing the sun. So what time of day is it with the other half of the Earth that's not facing the sun? Yeah, it's nighttime, right? And again, to sustain life, the Earth has to rotate for sunlight, okay? So again, solar energy directly hits only half the Earth that's facing the sun. The other half, right, it's nighttime, which is why we get day and night. Okay, that's where we get our day and night. Earth is spinning on its axis. One spin, 24 hours. So let's take a look at what we just talked about. So, right, we have our axis. As you can see, this line, right, starting at the North Pole, if you were to go all the way through the Earth to the South Pole, right, that line, that's your axis. Okay, and again, one rotation is 24 hours, right, and that's how we get our night and day. So we see the sun rays coming in, day, right, on this side of the Earth at the time. On the other side, it is night. Yep, as that darkness, right, represents. Now let's move on to revolution. So the Earth rotates around the sun, okay? So this path that the Earth takes around the sun is called an ellipses. Have we heard of that term before? Yeah, sound familiar? Okay, so that path that the Earth takes going around the sun is an ellipses. How long is one revolution? We go one time around the sun. Yeah, that's exactly right. One revolution is a year. To be exact, 365 in a fourth days, but again, we go by a year. So we consider a year 365 days. That's exactly right. Does anyone know what we have every fourth year? A leap year, that's exactly right. So because it is not a whole number, we also need to add a day to the calendar every fourth year, right? Does that make sense when we look at that 1/4? So every fourth year, we need to add a day. What month do we add that day to? February, that's exactly right. Next, we're gonna look at tilt. Okay, so the Earth's axis, right? We said it's straight line from pole to pole, North Pole to South Pole, is tilted in relation to the sun. So does the Earth travel like this straight up around the sun? No, right? When we talk about a tilt, we have a slight tilt in the Earth. So we're not straight up and down, okay? That's what we mean by having a tilt. If we didn't have a tilt, right, daylight hours would be the same at every location. Okay, so the sun would hit the Earth at the same time in every location. But because we have this tilt, right, daylight hours occur at different times of the day. So not every location is the same, okay? The Earth is tilted at 23.5 degrees, all right? 23.5 degrees. And that's where we have our tropics of Cancer and Capricorn. Do those sound familiar? Have we talked about, yep, tropics of Cancer and Capricorn. So a quick picture to show us what we mean by this tilt. Okay, so we have that Earth tilted at what degree? 23.5, right? So that tilt, right? The sun's rays spread over a narrow area, so the sun hits the Earth sooner here, right? And then the sunlight has to travel farther for areas right north and then south. Okay. So again, that's showing us how we get those different times, right? Different hours of daylight. So to review what we talked about today, rotation. How long does a rotation take? 24 hours, right? And that is the Earth spinning on its axis. That's right. All right, we have a revolution. The Earth is traveling around what? The sun, yes. How long is one revolution around the sun to be exact? 365 days in a fourth. That's exactly right. As a result of that, we have to have what every 4 years? Leap year, right. Perfect. Moving on to tilt. What degree is our Earth tilted at? 23.5 degrees. That is the tilt of the Earth, right? And that is why daylight hours are at different times around the world.